Good morning. Welcome to this webcast hosted by the National Nanotechnology Infrastructure Network's Computation Program at the University of Michigan. Our topic for today is solving for macro-scale electrostatic configurations using Robin Hood solver. Our presenters for today is firstly Toni Drabik. He has studied in the Faculty of Electrical Engineering and Computing in Zagreb before embarking on a successful career in trade press, writing, and testing equipment for a leading publisher of computer magazines in Croatia. He was head of company testing laboratory for several years, and he is currently marketing and sales director at Calculi Limited, a software vendor developing CAE solutions like the Robin Hood solver. Our other presenter for today is Hrvoje. He holds a master's degree in physics from University of Zagreb's physics faculty. He has worked at the theoretical physics department of Rutger Boskovic Institute in Zagreb. He has been studying and performing various numerical calculations of cosmic background radiation, black hole accretion disks, and has been developing electrostatic simulation engines, which has resulted in the creation of Robin Hood solver. He is currently a partner and CEO of Calculi Limited, and he will be joining us during the Q&A session. So without further ado, over to you, Toni.
Thank you very much. It is great to be able to welcome you all here to our presentation of Robin Hood Solver 2.0. Robin Hood Solver is a software package for electrostatic simulations and modeling. I expect this presentation to last around 40 minutes, and then we will have enough time for your questions and answers, and we will wrap up everything in, I hope, less than an hour. At the end of the presentation, there will be our colleague, Mr. Hrvoje joining us, and he will be able to answer some of your more technical questions. So let's start. Our company is a European startup, and our primary task is to develop Robin Hood solver. Robin Hood solver is a tool for electrostatic simulation and modeling, and it is based upon the Robin Hood method. The Robin Hood method is innovative boundary element method, which has smallest memory requirements on the market of the similar software packages. We are also able to produce custom graphical user interface and numerical models, both for Robin Hood solver and for the other software packages. Our software is based upon a Robin Hood method, a boundary element method which is matrix-free. So this is very important because the method only needs to memorize object elements. It does not need to create a memorized matrix, which makes it pretty fast, and also it makes memory requirements very small. The Robin Hood method itself is well known, and it is based upon the principle of taking from the rich and giving to the poor. It belongs to a class of greedy algorithms. They are called that way because they start from the most obvious place at the beginning of a problem, then fix what they can, and then they iterate the designated number of times. Robin Hood method itself has been used for many years in various fields for various problems. But this is the first time that the method has been used in electrostatic calculations. The implementation in electrostatics goes back several years, and you can find research papers about the method published in several journals in 2004 and 2005. If you need the exact references, you can email me after the presentation, and I will send the exact articles and publications to you. We will not discuss the methods in detail today, but I would like to point out that the method that we are using in this version, Robin Hood Solver 2.0, is improved version. It is not the original one that was presented in these papers. So what can you do with our software? For a start, you can do a sample calculation on your electrostatic model in just a minute or two and get a clear answer to your idea. There is no need for you to spend several hours creating a model and then several more hours to watch the results of calculations developing. If you want to find out something, it's possible to create objects and models in very short and to have results produced instantaneously. You can also impress your colleagues with impressive imagery. We will show the images throughout the presentation. And you can use it as a tool for introducing electrostatic concepts to your students. Robin Hood Solver is very useful for teaching basic electrostatic concepts, and we will also talk a bit more about this at the end of my presentation. We go on to more concrete examples. You can use Robin Hood Solver to charge density induced on surface of arbitrary objects, maybe or the electric one. You can calculate electric fields inside Faraday cage or even near sharp-pointed areas. This is important to pinpoint because many of our competitors have problems when doing calculations near the areas with many sharps. You can also calculate capacitance matrix of the touching electrodes, as we will show later in the example. You can solve electrostatic conditions while designing microelectromechanical. You can calculate the force particles, and you can even solve the distribution problems using electrostatic calculations, although this is not the main point of Robin Hood Solver. To summarize, Robin Hood Solver computes capacitance and capacitance matrix of the electrostatic model. It computes field and potential, and it is very useful for constructing and testing Faraday cages. The key advantages of our software are that it is a full 3D solver. It does not work on 2D objects, but on 3D objects instead. It has very low memory requirements, as mentioned previously, because the memory load grows linearly with the number of elements in the model. It also has very high accuracy because the errors do not compound and there is no critical slowdown. It is not possible in our software to get stuck at some point in the problem and be unable to move on, which is sometimes the case with similar software packages. The convergence of the calculation is exponential, and the user decides the level of accuracy versus running time. What does that mean? This means that, for example, if you need a very precise calculation, and we are holding the world record in some calculations for the accuracy, you can set Robin Hood Solver to run many iterations until it achieves the desired accuracy. But if you are satisfied with the higher error rate, if you have a tolerance, for example, 1 to 3% error rate, you can run the calculation and get the result almost instantly, depending on the size of your model. Also, unlike in many other solutions, we treat the electric charge as a basic element, and from that element, from the electric charge and everything else can be easily calculated. In practice, this means that the calculations in Robin Hood Solver are almost always divided into two parts. In the first part, after creating your model, you calculate the charge distribution on the object. And then in the second part, you execute the post-processing, which then gives you the electric field or electric potential. Our software runs on all three major platforms. We have a Windows version, which is most popular, but we also have versions for OS X and for Linux. These versions are feature identical, so anything that you can do under Windows version, you can also do under any of other two versions. We have tested the Linux version under many distributions, and we have so far found no problems running it and installing it. It is also possible to order custom-made modules from us and custom-made additional visualization features. What does this mean? For example, if you do a certain type of the calculation and you find Robin Hood Solver useful for it, but you would like to have a module which will be customized to that specific calculation in order to make it faster and to execute it sometimes in more convenient way, we can write and deliver that module to you. The same way goes for the additional visualization features. As you will see later in the presentation, we already have great visualization capabilities, but if you need additional visual sites and additional representations of the result, we can also write for you and deliver it in an additional module for Hood Solver. So the main features of Robin Hood Solver are easy to use graphical user interface, the use of advanced analytical techniques and precise post-processing capabilities, and they deliver results either very fast or very accurately. Robin Hood Solver uses a lot of less memory than you would expect from a software of this type. We have implemented a full-featured Lua scripting, which we will talk in more detail later on. We are able to import images and objects from other file types created in other software programs. And you can also use Robin Hood Solver as an external tool for software packages such as MATLAB, Mathematica, R, Python, or anything else that you are using. We also provide customer support in several different ways, usually very fast and to the satisfaction of our customers. We will talk about this at the end of my presentation. You start working in Robin Hood Solver by creating your 3D model of an electrostatic configuration. And it is possible, thanks to our advanced graphical user interface, to create the first model in just several minutes. You can create basic objects such as sphere, box, or cylinder just by clicking on a button on the toolbar. And you can combine these objects instantly using Boolean operations. On this image, on this slide, you see an example of such an object. This is an arbitrary configuration of spheres, boxes, and a metal plate. It has been created in Robin Hood Solver in less than 5 minutes. And this image shows the object as it looks like after the calculation has been done. You can also import existing models from or DXF files created in AutoCAD or other software packages. This is very important for those of you who already have large libraries of objects which you are using in other software packages. And this feature enables you import these objects instantly into Robin Hood Solver. You do not need to spend hours or days recreating them in the Robin Hood Solver from scratch, although it would be possible. It's not shown here, but it is possible to view and manipulate your model from different perspectives in Robin Hood Solver. You simply drag the screen with your mouse to see the object from the different angles, and you can also have top view or side view. We have built in the advanced project management system inside Robin Hood Solver, and the system automatically keeps track of all your projects. So you do not need to worry where all these files are saved, are they saved, to open them one by one, and so on. The project is automatic, and our software has no save command, because all changes and all operations that you make are saved as you make them. Also, all operations on your model are recorded in the history, and you can easily review and change them later. So what does this mean? For example, when you start creating your electrostatic model, you create an object, let's say a sphere of certain dimensions. And later on, you decide that you really want to create a larger sphere than the one you created. Then you simply go back to that step in your work history, and you change the dimensions of the sphere to new dimensions. And the Robin Hood Solver is able to execute not only the change, but also all subsequent performed operations automatically. So the whole model will be changed to reflect that single dimension change that you have. You can also save the main points in your modeling process as snapshots. Snapshots are saved states of your project, so you can go back to various branches and various states that had existed before. This is very important for those artists who create large several projects in Robin Hood Solver which last for even many weeks, and they are then able to simply retrieve the snapshots as they need them. Thanks to this project management that we have within the core of Robin Hood Solver, the software has excellent responsiveness, and it basically responds instantly to your command. As you can see from these images here, we have worked really hard to make the representation of the result very easy for you to make something out of it. After the calculation has been done, you can display the result as charts or as tables. You can compare these charts or tables side by side. You can also see the results visually in the form of various colors on the objects in the model. And this is not shown here, but the very important feature is that you can simply click on the part of the object, for example a triangle in the cylinder that is shown on the bottom left picture, and then Robinhood Solver will highlight this triangle, this element in the table of the result. So if you see something that seems just out of order, simply click it and you will be transported instantly to the numerical result of what has caught your eye. Here are some images that show the great visualization effect that Robinhood Solver is capable of. Our powerful post-processing engine allows you to create stunning effects in just a few moments. You can visualize electric field and electric potential using colors or using cones, and you can get a sense of detailed features of that field or that potential. Here are some examples of basic or more complex objects with their field and potential displayed using cones in the right-hand side of this slide. And here is the example which shows the power of our color palette in more detail. As you can see here in the bottom right picture, this is a basic configuration of a single metal plate above a single box positioned slightly below and off center of that plate. We have calculated the charge distribution, and as you can see by the colors, there is a lot more charge along the edges of the plate. We can magnify this. As you can see, the charge is distributed along the edges, and you can also use the top view to see the plate by itself. But this is a rough representation. If you wanted to see these things in more detail, you would need to tweak the color palette, which is done using just a few clicks in our property doc. And if you just tweak the settings slightly, you get different representation. This is the same plate from the slide before, but as you can see, we can use the colors to display the charge distribution. And if you tweak settings even more, the picture becomes even more clear. These are now those three images side by side, and please note that this is just a visualization effect. There is no physics involved, so to say. The basic calculation is the same for all three images, but by just tweaking the color parameters, you have changed the visual representation of the plate. And this enables you to instantly see the behavior of the plate in relation to the cube. In the latest version of Robinhood Solver, which is 2.0.10, we have also added contours, as you can see on this image here. The contours are borders which limit certain colors on the object, and you can customize these contours to your liking. You can instruct Robinhood Solver to automatically display contours on the object, or you can choose the number of contours. You can even display just one to limit the most obvious parts on the object, and so on. Here's another image which shows that you can use also release three-dimensional palette for the representation of the field and the potential, so not only 2D changes of color. And this is the final image in this, which shows that you can visualize electric potential using cones, which enables you to see the direction of the field more clearly. Besides working on the visualization engine, we have also invested a lot of time and a lot of effort to make your work faster and easier by automating it and by exchanging the results with your colleagues more easily. You can optimize your model using built-in Lua scripting, and you can use Robinhood Solver with other tools such as MATLAB, Mathematica, Python, or R. We have published all necessary API functions for you, and the users of Mathematica will be also glad to know that we are working on the specialized version of Robinhood Solver, which will be used as a plugin for Mathematica. You will be able to get it from the Wolfram market and to use it directly from Mathematica. All the results can be exported easily to CSV or TXT files, and you can then exchange these results with your colleagues, other experts, or in the case of classroom editions, with your students. You can also use other tools. For example, if you are using something as simple as Microsoft Excel to analyze the results, you can simply import these CSV files into Excel and then run your analysis there. It is also possible to pass these CSV files through your own scripts and so on. There are many examples of successful use of Robinhood Solver. Many of them are shown on our website at www.artcalc.com. One of the examples shows how to model capacitive sensors in Robinhood Solver. The example uses Robinhood Solver to simulate closed plate and open plate capacitive sensors, and then to determine the optimal distance between electrodes in the sensor. This is important for designing touch screens and similar devices. There is also another example which shows the use of Robinhood Solver in design of touch screens. In this case, the Robinhood Solver computes capacitance matrix of touch electrodes. And the example of our website discusses the usage of Robinhood Solver in simulating a touch screen exposed to use with one or two fingers. As you know, the touch screens are today one of the hottest topics in the technology research and development, and Robinhood Solver can play a great role in designing them and bringing them to market more faster and more efficient. Some other examples show the use of Robinhood Solver for calculating forces in actuators based on electrostatic cones, and also the use of Robinhood Solver with nanoelectronics. This is a basic example that shows how to calculate field and potential. We have created a simple model which contains a human hand inside a charged metal cylinder. This is a dielectric object with relative permittivity of 30. And Robinhood Solver first calculates induced charge density on the surface of the hand. The hand itself is, as you have probably supposed, important from the object file created in drawing software. It is possible to create hand directly in Robinhood Solver, but it would require a lot of effort, and it is much more faster and simpler to just import the already made object. The net electrostatic charge distribution can be visualized after solving is done, as it is shown on this image here. Electricity is visualized later after the post-processing part is done using the field cones, as you can see in the image right above. And speaking for cones geometry, we are able to present specific characteristics of the field in more intuitive ways, for instance, distribution and so on. For more clarity, you can even hide the hand and the metal cylinder and display only electric field just to focus on its specific characteristics. This is shown on the most bottom image. Robinhood Solver is also great for capacitance calculation. In this example, we are solving 2 and 3 wires above the metal plate. As you can see from the images, the wires are quite thick cylinders. Robinhood Solver really has no problem solving complex geometries on large objects, or even models which contain a combination of very large and very small objects. The capacitance matrix for the example from the previous slide is given in the table below. You can see the ID of each row corresponds to an object on the model. So in the graphical user interface you can easily see which result corresponds to which object. This table can also be exported to CSV or TXT data file, and then you can analyze it using anything else that you usually use for such tasks. Robin Hood, on previous slides we have concentrated on small examples, but as you can see from the image here, Robin Hood solver has no problems creating and solving even large models with many objects and with a large number, hundreds of thousands or even millions of elements. You can see here a model of a pickup truck, which is quite large. It was created in AutoCAD, and we have successfully imported it in Robin Hood solver and done calculations on it without problems on a simple desktop computer. You do not need a machine with 10 gigabytes of RAM to execute calculations in Robin Hood solver. Since we know that your time is valuable, we have also extended a lot of efforts to automate a lot of things inside Robin Hood solver. So to automate tasks and processing in Robin Hood solver, we have built in a Lua interpreter. We have chosen this language because it is very powerful and yet it is easy to learn, and it does not require a lot of computing resources. And it is important to know that everything that you can do inside Robin Hood solver can also be done from Lua scripts. So instead of creating and transforming, moving or resizing objects using toolbar, you can create and transform these objects right from the Lua script. You can also execute Boolean operations from scripts, and you can execute solving and processing from the script. We have included the simple script editor to write your script. Of course, you can use your favorite editor and then just copy and paste the script to Robin Hood solver. And we have also included a so-called Lua doc, which shows you functions inside the interface, so you can write your scripts more easily. The integration of Lua language, and it is fully integrated inside the Robin Hood solver, makes our software ideal for overnight optimization. So, for example, you can simply write a script to optimize your model, set it to run as you leave work, and retrieve your results in the morning. Then if you need to modify this script, you can modify it and set it to run overnight again until you achieve the desired result. In addition to use in commercial and research institutions, Robin Hood solver can also be used in universities to teach basic electrostatic principles to your students. You can use Robin Hood solver to create several basic samples and to distribute them to your students to solve and analyze. And this image here shows a basic example of a sphere and a point charge and the visualized charge distribution. From our experience, this is a great way to teach your first year students the basic electrostatic principles, because it is much easier for them to comprehend them when they see them visually than just out of the textbooks. You can in this way get your students acquainted with most common concepts. We created the Robin Hood solver classroom edition. Basically, it's the same solver as the regular edition, but it has the writing structure that more corresponds to use in teaching. There is an example video of Robin Hood solver 2.0, you see on our YouTube channel. Here's the address, website. I will not show the video here, unfortunately, because the internet connection is a bit slow, and in our test yesterday the video did not play smoothly. But simply after the presentation, visit this address and find the video, set it to run in the full screen because this is HD video, and you will be able to see in great detail how Robin Hood solver can be used to create and solve basic electrostatic model. The video lasts 5 to 6 minutes, and I think it's very well worth your time. In the future, we will implement the GPU parallelization in Robin Hood solver. We have done some tests, and we have found out that this greatly increases the speed of calculation. The work on GPU parallelization is practically at its end, and we expect to release the GPU-enabled version in the summer of this year. There are also plans to implement so-called off-trees in post-processing, and this will also speed up the post-processing for several hundred times, at least. That is the results from our tests. We plan more improvements to the graphical user interface and many other improvements based on customer suggestions. We have done in the last several minor versions many little tweaks to features such as color collections and so on, mostly based upon the suggestions of our existing customers and the people who are using Robinhood Solver demo version to evaluate it. I have not mentioned it before, but maybe it's worth mentioning. Robinhood Solver uses SI units, so it's pretty standard, and if you have used similar software which is a similar unit system, you will not need to adapt to anything else. Some users have been kind enough to share their feedback about Robinhood Solver publicly. So one of the first users of Robinhood Solver, he got several years back version 1.0, and he claims that the speed and the price are amazing, that it beats any other software that he can find on the market. The tool which uses Robinhood Solver on the Massachusetts Institute of Technology. His colleague Joe Formaggio also uses the Robinhood Solver on MIT, and I especially like this quote because he says that problems that seem impossible to solve now are common routine with Robinhood Solver. One of the colleagues from the Brown University also used Robinhood Solver for his research project, and he was especially impressed that he was able to run many cases and many simulations on personal laptops, so that was the lower-end machine, with ease, and even the running simultaneous multiple instances was within reach. So performance-wise and memory-wise, Robinhood Solver is really a great tool. How do we support Robinhood Solver? With every copy, even if it's a demo version, you get included a full manual in PDF and HTML file format. There are many education videos at our YouTube channel, and we are adding new videos every few weeks as we are able to. There are many examples at www.archive.com, and there is a ticket-based support site and forum at support.archive.com. We usually respond to all support questions within 24 hours, and our customers and demo users are usually very satisfied with the response. You can get a free demo version of Robinhood Solver at www.archive.com/demo. You simply fill the form in which we will ask you to give your name and email address, and you will get the download links for the current demo version automatically. This demo is fully functional. This means that all the features are present. Save function is also enabled. You can save the project and retrieve them later. And the only major restriction is that the solve function will ignore all objects which contain more than 500 elements. So if you have several objects inside your model, these which contain more than 500 elements will simply be ignored by our calculation engine. But we believe that this is enough to get yourself acquainted with the features of Robinhood Solver. So thank you for your time, and now we are going to the Q&A session. I'll just ask for a small pause of under a minute until my colleague Mr. Hrvoje can join us. Thank you again.
Thank you, Toni, for the presentation. We'll now take questions from the audience.
Okay, any questions, you can ask them now.
Hello, can you hear me, Toni?
Yes.
Okay, we have a question. The question reads, I am currently working on micro electrostatic tweezers and I am new to the software. Can you help me in designing it?
Yes. The person who asked the question, I asked him or her to simply send an email with the question to the email address info@adcalc.com or to my email address which was shown at the beginning of the presentation, and then we will answer this question and help with the creating of the model in the next 24 hours.
Alright. Yeah, we have one more question. Does Robinhood Solver support reduced order modeling?
Excuse me, does Robinhood Solver support?
Reduced order modeling.
Just a moment. I'm not really sure what the question means by it, but if he can clarify it either in an email or here in a message, we will be able to answer it.
Okay. We have one more question. Can I simulate anisotropic permittivity using Robinhood Solver?
At this moment, it is not possible. This person is some object, so it is not possible to do this right now.
Can you repeat that, Toni? Your voice broke.
Sorry, can you hear me now?
Yeah.
Okay, so at this moment it is not possible since we support homogeneous objects at the moment.
We have one more question. Does Robinhood Solver support multi-physics problems? Can I solve coupled problems such as electrostatic structures interaction?
Currently we do not support multi-physics problems, but you can combine the Robinhood Solver with other tools and then solve your problems in combination with several tools. We can answer specific questions on how to do that if the questionnaire will send us email with exact specifications, and then we will instruct him how to do so.
Okay. Do we have any other questions? Okay, we have one question. Which boundary element method does this software support? Is it the iterative method or the induced charge computation method?
So the Robinhood method is a specific method, but it is most close to induced charge method.
Do we have any other
The
questions?
most similar to induced charge method.
Okay. I guess we've taken all questions, so we'll end this event for today. Thank you, Toni and Hrvoje, for the wonderful presentation, and the attendees. Thank you for attending today's webinar. If you'd like to view view a copy of this webinar, you will be able to do so in a couple of days by visiting our website, that is https://lnf.umich.edu/NNIN@Michigan. Thank you all, and have a nice day.
Thank you all for listening in, and bye.